This topic is the last of our hypothesis testing, and it's for a proportion. So remember a couple things for a proportion. If we have a sample of size n, then we define the proportion as x over n, where x is the number of successes. Furthermore, I'm going to use a subscript p, even though your book doesn't use this notation. I'm going to use it to indicate that I'm dealing with a proportion. The mean was given by n times p, and the standard deviation is given by the square root of p times 1 minus p divided by n. And the z-score, so when you see that it's a z-score, you know you're going to be using the normal distribution table. We'll have p hat minus p divided by sigma sub p. And let me do this. Let me call it mu sub p. This will usually be given in terms of the problem then. And the sample mean, or sample proportion, is listed with a little hat on top of it. So I'll typically say p hat for something like that. It turns out then that these proportions form a normal distribution. Here's some assumptions that we have to make, though. One, the sample is random. We always make that one. Second assumption, x itself is a binomial, let's say binomially distributed. And then this last one is that we need n times p to be greater than or equal to 5, and n times 1 minus p to be greater than or equal to 5. If it satisfies these, then we have ourselves a normal distribution of proportions. Let's do some examples to illustrate this. Here's our first example, but before I do it, I want to scroll back up for a second. I made a mistake in what I wrote. Right here was a mistake. We don't put that mu sub p there. In fact, I really don't care about mu sub p in this problem at all. What we're going to be trying this against is a proposed population proportion. So the little p is the population proportion. Now with that fixed, I can go back to the problem that we were working then. We have a researcher claims, based on information, that 23% of Americans say they dream in black and white. So this here is the proposed P. To test the claim, the researcher randomly selects 100 Americans, so there's our N, and found that 28, there's X, said they dreamed in black and white, and there is our alpha level. So first of all, let me determine what kind of a test this is. We have, based on information, 23% of Americans say they dream in black and white. To test this claim, so they're claiming that P equals 23%. So here's what our null and alternative hypotheses are going to look like then. So the claim is that the proportion is 23%. So the second part must be not equal to 23%. So notice this is a two-tailed test. Well, let me get my sigma, because we'll need it in some of my problems here. That's the square root of p times 1 minus p divided by n. So here then, p is 23%. I'm going to convert everything to decimals. That's 0.23. 1 minus 0.23 is 0.77. And then we had 100 people in the sample. We get 0.0421. Let me draw a picture of the situation. So here I'm converting to decimals. Now our sample, we do need to calculate the p prime. So let me put it up here. P prime, p hat is really how it's said. That's x over n. So we have 28 over 100, which is 0.28. So that is to the right. And so the p-value that we're looking for is over there in the shaded region. And then we'll get our z-value. So remember, that's p hat minus p all over sigma sub p. So p hat was 0.28 minus 0.23 divided by 0.0421. We get a z-score of 1.19. Let me draw a new picture with that. 0, 1.19, and then there is our shaded region. So our p-value here I get 0.11702. And now let's take a look at my p-value versus alpha. Be careful here, actually I forgot. Since this is a two-tailed test, you do half alpha like normal. So let me go back up here and see what the alpha. Alpha was 0.025, so I'm going to divide it in half. 0.025. And the p-value is greater than alpha, so do not reject H naught. Here we have a report stated that 31.9% of babies are delivered by cesarean section. So we'll call that P. A researcher believes that the percentage is less than 31.9%. So that tells us how to set up H naught and HA. So I can put P is less than 31.9% here. So that's the claim. And we're left-tailed. And then up here we must reverse and put it equals under there. All right, so the researcher randomly selected 50 newborn infants, so there is N, and found that 13 were born by C-section. There's X. And there is our alpha level. Let's go ahead and get the numbers I need. So my P hat will equal X over N. That's 13 over 50, which is 0.26. And then our sigma sub P, that's the square root of P times 1 minus P divided by N. P here is 0.319. 1 minus 0.319 is 0.681, and N was 50. I get 0.0659. Let's draw a picture of the situation. There's a 0.319, and our 0.26 is over here. Make my decimal a little better. Now let me get a z-score. That's p hat minus p divided by sigma sub p. P hat 0.26 minus 0.319 divided by 0.0659. I get negative 0.859. Actually, I made a mistake, 895. But you can only go to 2 decimal places in that table. So I'm going to round up to negative 0.9. And let's draw a picture. 0, negative 0.9. P-value equals 0.18406. And now we're ready to do our decision. Our p-value 0.18406 versus whatever alpha was. Alpha was 0.01. So the p-value is larger, so do not reject H naught. Here we have a statistician has read that at least 77% of the population oppose something. I really don't care what it is they oppose, but this at least is important. That's an inequality. That's greater than or equal to. When you say something is at least something else, it's greater than or equal to that. And this 77% here, this is going to be my proposed population proportion. To see if this claim is valid, the statistician selected a random sample of 80 people. So there's N. Found that 55 were opposed. So that's X. At alpha equals 0.01, test the claim that at least 77% of the population are opposed to the change. So since at least has an equal sign underneath of it, that has to go into H naught. So we're saying P is greater than or equal to 77%. And then reverse it and make it a strict inequality the other way. Here we're going to have P is less than 77%. So up here was the claim, and down here we need to note that it is a left-tailed test. Let me get my numbers over here. P hat, that's X over N, X being 55 divided by 80. Sigma sub P equals the square root of 0.77 times 0.23 divided by 80. .6875 for that one. 0.0471 for the standard deviation. Let's get a picture. And we have slightly less for our p hat, so it goes to the left. Now let me go get the z value. Z equals p hat minus p divided by sigma sub p. I get negative 1.75. Let me draw a new picture so that I can use my table. For the p-value, I got 0.04006. So we'll compare our p-value to alpha. And let's see what they specified alpha to be. Alpha was 0.01. P is greater, so do not reject H naught. An attorney claims that more than 25%, so they've already given us two pieces of information already. HA, they've told us that P is greater than 25%. That's the claim. And notice that it is right-tailed. So H naught must be that P is less than or equal to 25%. Here's our N, 200. 63 had used some form of advertising, so there's our X. There's alpha, 0.05. And let me get some of my preliminary numbers here. I have 63 out of 200, which is 0.315. Sigma sub p equals the square root of 0.25 times 0.75 divided by 200. I get 0.0306. Let's get a picture. Centered at 0.25. And our sample was 0.315. Let's get our z-score. To two decimal places, I get 2.12. New picture. P-value. That equals 0.0017. And now finally, to finish this off, let's find our alpha. Where are you at, alpha? Alpha is equal to 0.05. Well, this time alpha is bigger than P, so this time we should reject H naught. The percentage of physicians who are women is 35.2%. There's our proposed proportion. In a survey of physicians employed by a large university health system, 56 of 120 randomly selected physicians were women. Is there significant evidence at the 0.05 level, that's alpha, to conclude that the proportion of women physicians at the university health system exceeds 35.2%. Exceeds is a word that means greater than. So we know that that has to go into the alternative hypothesis. So we'll have P greater than, well, I'm going to keep it as percentages for my statement. 35.2%. This is the claim. And we can see that it's right-tailed. So then H naught, P has to be less than or equal to 35.2%. My P hat, that's X over N. So that's 56 divided by 120. My sigma sub P, that equals the square root of 0.352. 1 minus 0.352 is 0.648, and we had 120 in the sample. 0.4667, 0.0436. Picture of the situation. Z-score. To two decimal places, I get 2.63. New picture. The p-value equals 0.00427. Alpha, let's go and find that thing. 0.05. And we can see that alpha is bigger. So we reject H naught. Here is one last example. Let me get my letters while I'm reading along here. It has been found that 85.6% of all enrolled college and university students in the United States are undergraduates. A random sample of 500 enrolled college students in a particular state revealed that 420 of them were undergraduates. Is there sufficient evidence to conclude that the proportion differs from the national percentage? And there is our significance level. So differs from means does not equal. So I know how HA is going to look. P does not equal 85.6%. And this here will be our claim. And it's two-tailed. H naught, that will be P equals 85.6%. Let me get my P hat. My P hat was 420 divided by 500, which equals 0.84. Sigma sub P will be the square root of 0.856. 1 minus 0.856 is 0.144, and I will divide that by 500. (0.0157). Picture. And our p hat was a little bit smaller. Come down. Z equals p hat minus p all over sigma sub p. To 2 decimal places, I get negative 1.02. New picture. P-value 0.15386. And finally, to finish it off, p-value 0.15386. And remember, this is a two-tailed test, so take half of alpha. That would be half of 0.05. So we get 0.025. So we can see that P is bigger. Do not reject.